Only if they're on the test, okay. Everything I bring, I'll put on the test? It'll be a long test. Okay, now, magnetic uranium deposits, sorry.
Hello, my name is Chelsea Crandall, and my presentation today will be on magmatic uranium deposits. Now, uranium is a fairly well-known element. It's usually the first radioactive element that people think of. Its two main uses are in nuclear power and in the military. Oops, sorry, hit the wrong button. So, obviously in nuclear power, it's the main fuel used in nuclear fission reactors, and it's a very efficient in comparison to most fossil fuels. Approximately 1 kilogram of uranium is roughly equal to 1,500 metric tons of coal. So it's very efficient, but it is also potentially dangerous to people working there and to the environment. Now, as for its military uses, most of us, the first thing we will think of is its use in thermonuclear warheads, but actually it's much more commonly used for its high density and hardness. It's used in high-density penetrating projectiles, so armor-piercing bullets and things like that. It's also used in tank armor and actually in radioactive shielding. Even though uranium itself is radioactive, it's much more effective than lead at shielding from more radioactive elements like polonium or radium. Now, since this is a geology class, we're more interested in uranium's chemical properties. Uranium is a large atom down here at the bottom of the actinolite series. It's element 92, so it's really big, huge atomic radius. It's very high charge, usually +6 or +4. This makes it highly incompatible, but it's also highly soluble. Now, because uranium is so incompatible, it's usually found in highly differentiated magma bodies. This can be anything from a syenite to a pegmatite to an elastkite, otherwise known as leucogranite, which is a highly alkaline and differentiated granite. Now, because it's so incompatible, it's usually found in the very latest stage magmatic fluids along dikes and veins, as we can see in this diagram. These little dikes and veins are where you would find the uranium. And because it's so soluble, it's usually found in areas of high hydrothermal alteration. Now, fluctuations in the oxidation conditions of the water are what will deposit the uranium. So changes in pH or changes in the oxidation state of the wall rock will cause it to precipitate out. The wall rock can also further concentrate it depending on whether or not uranium can replace with other atoms. Now, because of its high charge, it can't usually replace it with things, but it has been known to replace with carbon and carbonates and silicon and silicates. And when it's not replacing with things, it's usually deposited as uranium oxide, which is usually U2O2 or U3O8. And as we can see, it's got about 6 electrons on its outer shell, but it can also just strip off 4. Now, extracting uranium is made slightly easier due to its soluble nature. It's kind of hard to get it out of the granites because it's a very hard, impermeable rock. But it's usually leached out using acids and alkaline fluids. If it's a silicate or an oxide, it'll be leached by acids. But if it's a carbonate, it'll be leached by alkaline fluids, usually sodium or calcium rich, and is refined into yellow cake, which is the fuel used by nuclear reactors. It's just a uranium oxide. Now, obviously, there are going to be a lot of issues with mining uranium because of its political connotation and its environmental hazard. Uranium is a political hot topic because of its association with nuclear bombs, and it is also a huge environmental hazard, very potentially dangerous. So politics have a bigger effect on uranium's economy than anything else. The demand is very much dictated by how politics are viewing uranium at the time. For instance, the Fjarnefeldi uranium deposit in southern Greenland is one of the richest uranium deposits that we've ever found. but mining has never started because Greenland has a zero tolerance for nuclear power, nuclear weapons, even just mining uranium. They won't let it. So environmentally, uranium is a huge problem because it's so soluble. It can easily be washed into groundwater, lakes, streams, whatever you have around. So you have to be very careful. In addition to that, the acids and alkaline fluids used to leach it out are also potentially very harmful. So every step of the mining and the refining process has to be very carefully monitored and handled and disposed of and contained with the utmost care. Now, as far as price goes, uranium has been hovering at about $35 a pound for the past year or so. It's been on the down drop lately, and obviously it's got the big spike around 2008, like pretty much everything else we've seen. It's a fairly common ore, so it's typically mined in high grade. However, the Rossing mine in Namibia, Africa, is one of the biggest uranium mines in the world, probably the largest one related to a magma body. And since it's such a large-scale operation, they actually mine a fairly low-grade ore. And as time goes on and as we move away from fossil fuels and we sort of perfect the process of nuclear fission reactors, it's likely that the price of uranium will go up as nuclear fission reactors become more common. But again, that really ties in more to politics than anything else. And even though we've had some technical advancements, people are still very scared of nuclear power because of its potential dangers. So where the price goes from now is still kind of a mystery. And thank you for listening.